An India of innovation. In recent times, the world has come to know of this vast country's growing importance in geopolitics and business. But what of its achievements in science and technology? Join me, Rob McBride, as we go around India by land, by sea and air on a science safari. In trying to answer the big questions about the origins of the universe and where we've all come from, you could start in this part of rural India that's home to a unique facility picking up signals from the farthest reaches of outer space. As a facility, there's only one of its kind. 30 antennae, each 45 meters in diameter, spread over a 20-kilometer stretch of Maharashtra. And all focused on trying to unlock the secrets of the universe. The GMRT, or Giant Meter Wave Radio Telescope, was located here north of Pune after an extensive search for a site that was reasonably free from radio interference. And it represents one of India's biggest science projects to date. Dr. Arvind Gupta has seen the GMRT evolve, starting from its highly innovative design. Using a mesh instead of a solid surface, the structure of each antenna is extremely light, given the amount of reflective area it provides.
The way the panels have been designed, it is something unique. The design is called SMART, which stands for Stretched Mesh Attached to Rope Trusses. So the whole thing is supported on trusses, and as a result the whole cost has come down significantly.
Where GMRT excels is in its ability to look for and detect clouds of hydrogen gas from which it's believed the first galaxies were formed. By finding those early primordial clouds at the furthest reaches of space, we can better understand how the universe came into being. The GMRT has quickly become a favorite for astronomers at home and abroad. It receives 100 requests annually to be involved in different projects, a third of them from overseas. Working at relatively low radio frequencies of about 100 megahertz up to 1000 megahertz, the GMRT finds itself occupying an important niche, and it performs better at low frequency than its counterparts in New Mexico in the United States. Its services constantly in demand, the staff of scientists and technicians working shifts around the clock, keeping the facility running. In doing so, they employ impressive computing power, not only to process the images being received, but also to coordinate the precise movement of all the dishes as they scan the heavens for the faintest of signals. Thanks to the GMRT, that two new discoveries have been made in recent years, both involving pulsars.
Pulsars are very special kinds of objects. They are actually what we would call dead stars. They are the remnants of a supernova explosion when the central core of the star collapses to form a very dense ball of neutrons, literally neutrons.
Indeed, the whole field of pulsar research is an area that has occupied astronomers for several decades, since the discovery of the first pulsars in the late 1960s. And as more are discovered, they further test our theories of physics. One of the pulsars found by Dr. Gupta and his colleagues is a binary system, a pulsar circling another object with an exceptionally eccentric orbit which has intrigued scientists.
There is this sphere of 10 kilometers which is spinning around at tremendous speed, and these stars then emit beams of radio emission from the two poles of the magnetic axis. And you see those beams, just like a lighthouse beam that goes around. Every time the star goes around, you see one blip, except the blip is a radio pulse. And so they are called pulsars. It's a science which gives you thrills and also puts you in the right perspective of your place in the universe. So you get the thrill of, finding something new and something which has such significant implications for the history of the universe, something which goes back to what happened billions and billions of years ago.
As radio astronomers around the world look ahead to the next generation of radio telescope, so the GMRT provides valuable inspiration.
Oi, okay, that's fine. Namaste, thank you. With its agricultural base, India knows all about living off its land, even the poorest of soils. Now that expertise is about to become especially useful as India, like every other country, looks for alternative fuels to drive its engines. On a hot day, there's nothing quite like a cool Merc to get you around. But what makes this Mercedes-Benz even cooler, especially in these days of diminishing oil reserves, is exactly what's driving it.
It was this type of vehicle, in addition to a Mercedes-Benz van, that car maker Daimler Chrysler successfully converted to run on biodiesel, developed in conjunction with local Indian partners.
Single way, yes, single way.
The biodiesel has been obtained from the Jatropha plant. It is a common weed that grows across India and on some of its most degraded soils, and the production of biodiesel from it is capable of reducing emissions of carbon dioxide.
Considering it would come from some of the roughest terrain in India, the fuel actually gives an incredibly smooth ride. We've been on these highways now for several hours and the car has been performing beautifully.
There's a time for play and a time for learning, and sometimes a time for both. Toys and games, all based on simple science, aimed at stimulating the young scientist in all of us, and made from everyday household objects that we'd otherwise throw away. They are the creations of this man, Arvind Gupta. An engineer, teacher, toy maker and book lover. Someone who is himself still as fascinated by the science around us as he'd like his young protégés to be.
You make a toy train with this. Now this is like the two parallel lines, like the railway track, and this is the engine, right? And it starts from Shivaji Nagar station, right? And it comes to the Pune junction, which is the terminus. It doesn't go back to Shivaji Nagar, right? And if you stick a picture of a monkey on this, it will look like a monkey climbing a coconut tree, right?
Appealing to a child's natural sense of curiosity, he never fails to cast his spell. In his time, he's invented hundreds of innovative ways of introducing science to children. This, a humble coin and a coat hanger to illustrate the complexities of centripetal force.
slowly lift your finger and make it vertical. And you can't do that instantly. Because there's so many forces, you've got to experience them. It's a very complex thing. And now this is, well, you can stand a combo like this.
Simple demonstrations aimed at being understood by the simplest of minds, in theory.
Yeah, I'm sure I'll get the hang of that eventually. Yeah.
Keeping simplicity and affordability as his guiding principles, Gupta's mission is to show how even the poorest communities can excite the young with the magic of science by drawing from the growing amounts of waste we produce. Discarded drinks packs, cycle inner tubes, toothpaste tubes, batteries and film canisters all can find a new life as scientific tools. Gupta believes children should be brought up to regard waste as the birthplace of new creation. And he has every right to blow his own trumpet.
For children, the whole world is a laboratory. They're doing science all the time without being told that. Children learn a great deal without being taught. Now, this is adult arrogance that we teach. Children were born learners. They were born to learn. So they're learning all the time.
With ever more demand for innovators in science and technology, many future leaders may have been created.
Oh.
There you are.
Oh my God. I can do it. I'm a scientist. Oh my God.
Go ahead.
Single-handedly, he has drawn thousands of children into the magical world of science.
Basic scientific principles from the simplest of everyday objects. But from the small things, big things can grow. Out on the tarmac with the LCA, getting ready for test flight number 526, the latest in its rigorous development program.
The LCA, India's light combat aircraft, small, lightweight and multi-role, a supersonic warplane that is the result of largely Indian innovation and development.
This is actually a symbol of what India is willing to do in this field, and it was taken up to replace the very large fleet of MiG-21 series what we had, and we took it up almost 15-18 years ago, this program. So it started off, we had to evolve the technologies in the program, and then we had to actually develop the aircraft. And we are very, very proud of it because the aircraft is a unique one.
Incorporating some key technologies from the use of carbon composites in the airframe to its advanced avionics, the result is lightweight strength and agility.
The whole design concept is an exceptionally high degree of maneuverability, a lightweight fighter which can carry a phenomenal payload, easy to operate, and something what we did ourselves exactly the way our pilots wanted this aircraft to be.
No other aircraft before in India has employed carbon composites instead of metal to such a degree. It means apart from making it lighter, the sleek delta wing shape is relatively free from joints and rivets and makes it harder to detect by radar.
The basic empty weight of the aircraft is kept low because you are not putting metal in the aircraft. The second thing is that the radar signatures are very, very low, and then it's a technology which is easy to repair. The aircrafts will not corrode, will not rust.
Through the LCA project, Indian engineers have found themselves becoming expert in working with the new material.
Here in the construction of prototype number 3, you can see just the amount of composite material being used. In fact, a full 90% of the surface area.
like master chefs, fashioning each section ready for the oven. And the proof of the pudding, testing every section of the skin before going off for assembly. A supersonic aircraft of such sophistication requires extensive supersonic testing, and in the development of the LCA, 7,000 separate visits were needed to the wind tunnel. The wind tunnel is an essential aid in the design and development stage, optimizing the aerodynamics for such a high-performance machine.
Yeah, what we are trying to do in a wind tunnel is to recreate what happens up there in the air on the ground. There you've got an aircraft moving and the air is around it is still. Here we do the opposite. We have a model which is still, sort of still, and we push air through. So we're looking at what kind of pressure loads it has to withstand. There are lots of questions the designer wants to know, and we're trying to find answers for these questions.
Pretty much any indigenous machine that has taken to the skies over India has graduated from this facility, from planes to space rockets.
Once your flow starts misbehaving, once there's separation, once there's turbulence, then I'm sorry, the best mathematical equations are still not often good enough. And even if the equations are good enough, I'm not sure the computers are good enough yet. And even if the computers are good enough, I'm not sure they are fast enough as yet. So the wind tunnel is going to stay.
All the R&D, all the innovation, all the effort. The result, an awesome machine, almost ready for active service. The LCA has equipped the Indian aerospace industry with indigenous capabilities. Avionics and advanced engineering gained through India's own efforts, overcoming technology transfer barriers.
There was so much of skepticism that we may not be able to make it. Today we have done it. Not only done it, we have convinced our own users that they would definitely say the flying qualities are better than Mirage. Today I can tell that we have bridged that gap of 30 years of technology, and we are contemporary with most of the world. If in future when we take up the next generation fighter aircrafts, that aircraft will be definitely comparable with any of the future fighter aircraft.
Digital fly-by-wire technology to help the pilot operate the machine smoothly and get the most from its performance is essential.
All right, so we're in the simulator of one of the world's most sophisticated fighter aircraft. How difficult can it be?
The answer is very. A new generation of pilots for a new generation of warplanes. Space research took off in India in 1961. And from a standing start without the military and industrial muscle that supported the space endeavors of the superpowers. Following the launch of the Aryabhata satellite in 1975, India has launched many remote sensing and communication satellites. It is a story that begins here in Tumba, on this remote part of Kerala's coast, and at the local church. When the space program began here, this landmark was one of the few permanent buildings in this fishing community. Now a museum, its many exhibits tell the story of India's endeavors in space. From the launch of relatively simple sounding rockets up to the edge of space, to the development of much bigger launch vehicles that put satellites into orbit.
From massive satellites to much smaller payloads. This, a weather rocket about to be launched this evening from Tumba, the cradle of the Indian space program and where it all began.
In preparation for launch, warning flares as the rocket is made ready. This a regular fortnightly launch from Tumba to test wind speeds in the jet stream high in the atmosphere. From the very start, the goal of harnessing space exploration to serve the needs of humanity has been pivotal in the Indian space program.
Stand by for time mark at T-minus.
Safari. Now that's what I call a safari. There's a big chunk of India right there. Are we fit? Are we set? Let's go.
Early morning in Vasco near Goa, and the boats are heading out to work. At the helm of his boat, Sydney, an electrical engineer by training who chose to fish because of his interest in the sea. His job made easier thanks to information gathered via satellite, which tells him where to fish.
The potential fishing zone advisory is useful to quite an extent, especially nowadays we cannot waste time searching for fish. So if we have a potential fishing zone advisory, we know the zone where the fish is good. We have more chances of catching the fish, so we waste less time and less diesel.
A simple fishing boat from the outside, inside it's a platform for the latest technology.
I use almost all the latest equipment in my boat. I've got a DGPS on my boat, that's a differential GPS. Then I've got a Eco Sounder fish finder. I've also got a sonar that detects fish at a range of even 400 meters away from my boat.
But to put him that close to the fish, he needs to know which part of the sea to be fishing in. That's where the potential fishing zone advisory comes in. High-tech data provided by ocean scientists, marine biologists and remote sensing experts.
What happens here is we process operationally data from NOAA satellite. We get sea surface temperature. Then we process data from IRS-P4 OceanSat, which is the Indian satellite which gives chlorophyll. We identify features that are important for fish aggregation like meanders, eddies, rings, etc. And then we actually mark it as these features, we transfer it onto the hydrographic office charts for the fishermen so that they can easily understand.
The result for Sydney and his crew, bigger catches and less effort in securing them. With its extended coastline supporting 10 million people from fishing, an application of satellite technology that has a profound and direct impact on fishing communities around India. From the fishermen out at sea to the women selling the catch in the local markets.
Flip that one. What's this one called? Huh? Cobra. Nice, tasty. Cobra. Kitna?
ये पूरा 50.
हाँ?
पूरा 50 रुपए.
2 rupee, 5 rupee. 5 rupee. 5 rupee.
कौन सा गांव से आया?
I don't know. I'm not. Which village? Okay, village of Hong Kong. Hong Kong village. You know? Yeah, small village near China.
टीवी में दिखा था.
China. I come from China. Do you know China?
पूरा टीवी चल.
But I'm not very Chinese. Get out of here. We just chatted all day long.
Learn the local dialect and then how to haggle or get a rod and do it yourself. Back on safari to Delhi, to the International Centre of Genetic Engineering and Biotechnology.
This section here, we do work on drug development, and in this lab over here, we do our work on developing malaria vaccines.
Dr. Chetan Chitnis is at the forefront of an epic struggle with a very old enemy. The battle has been waged for decades, but finally an end could be in sight, thanks to a long sought-after vaccine for malaria.
Okay, tell us, Doctor, just how much of a challenge is malaria to human health?
Well, malaria is still one of the major killers in terms of infectious diseases. It's estimated there are about 300 million cases of malaria each year, and they account for about 2 to 3 million deaths, mainly of small children.
With the various strains of malaria becoming ever more resistant to the drugs used against it, there has been a growing urgency to find an effective vaccine that prevents infection in the first place. It has required a radical rethink on how the parasite works and how it can be killed.
Tell us, how does the vaccine work?
We have cloned the gene for the Duffy binding protein, and specifically the part that binds the receptor. We put it into E. coli and then grow the E. coli in this fermenter. And the E. coli produces the protein, and as I'll show you in the lab next door, we then purify the protein from E. coli, and that is the vaccine. If you immunize people with that protein, people will make antibodies, and those antibodies will block the binding of the parasite to the red cell and not allow it to invade red blood cells, thereby killing the parasite.
In achieving their breakthrough, the team have further proved the effectiveness of public-private partnerships and how challenges as big as defeating malaria require a multi-agency approach. One of the production lines at Bharat Biotech, an innovative leader in Indian pharmaceuticals, having already made a name for itself with its novel technique for producing hepatitis B vaccine, which is far less capital intensive and has resulted in far less chemical byproducts.
We thought, we should be innovative, come out a much more safer vaccine, and at the same time bring the cost down. And that was our goal. And we developed a HiMax, a new technology, which we got a global patent.
Thanks to Indian pharmaceutical firms, the costs of many drugs now available for people in developing countries have come down dramatically. Indian patent laws allowed for companies to find ways of producing generic drugs through more cost-effective and innovative means than their counterparts in developed countries.
Reduction almost more than 10 times. That brings almost, vaccine which is sold at $20 a vaccine, we're able to bring it 20 cents. I think India, to be a developed nation, innovation is the most important.
With lower production costs and an obvious abundance in talent, India is at the threshold of an exciting era in pharmaceuticals, medicine and biotechnology. One that will see it emerge in some respects as a world leader, and with the people and communities benefiting being those most in need. The timeless face of rural India, unchanging from generation to generation, but in the space of one lifetime, about to undergo a profound transformation unimaginable to our forefathers. We have come to the village of Januru in Andhra Pradesh. Outwardly very ordinary, but the appearance of the antenna means life will never be the same again.
Out in a field, online and able to check my emails. The pace of connectivity in rural India has been, as we all know, phenomenal. The pace of rural development itself, less so. Using the one to help drive the other, now that would be the thing.
Technology enabled, this is Project Ashwini. At a rural centre, students gather for their daily lesson from a teacher situated in a classroom many kilometres away.
Good morning children, how are you?
A total of 32 Ashwini centres, able to reach up to 500,000 people in the rural communities they serve.
Madam, please say about the advert.
Sessions that are interactive, inviting response and participation from those involved. Their remoteness no longer a barrier in this age of internet connectivity. The Bairaju Foundation employs teachers to run classes in continuing education programs using their Wi-Fi network.
Alas, wow, hooray. Well, where we will use this hooray?
And in addition to the more traditional classroom sessions, use of other mediums such as puppets to help tell stories and impart public information. Additionally, these centres can be hooked up with studios in Hyderabad, several hundred kilometres away, to draw on the services of experts in disciplines from agriculture to health. All of these influences, ensuring the society these children inherit and pass on, will be very different from the one they were born into.
Right down the camera. You think it's a still camera, don't you? Tell me, what's your name?
My name is Satyaramya.
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 Okay. And how old are you?
I am 10 years old.
Tell me about school. Do you like school?
No.
You don't like school? Who else speaks English here? What's your name?
My name is Raj.
Give me 5. No. Dude! Bye-bye.
See you.
Bye.
See you.
See you. See you again. Bye-bye.
The revolution provided by the digital age potentially benefiting all down to the poorest of farmers.
I'm in a field with a bunch of farmers looking for grubs. Not quite sure what type of grubs we're meant to be looking for, but then that's the point. Once we find them, then we'll identify them.
Another application of the technology.
But we found one.
Aimed at helping poor farmers, the scheme is called Isagu. Coordinators regularly visit farmers and listen to problems. They also take pictures of pests and diseases affecting their crops. These are then sent across the internet to experts. In turn, the experts give analysis on what the problem is and how to tackle it.
Thanks for talking to us. I'll let you get back to work. Thank you.
Thanks.
Looking at scientific work that helps farmers inevitably leads to ICRISAT. The International Crops Research Institute is a non-profit body. They operate in 50 developing countries, helping the poorest of farmers.
All the innovations we've seen so far having a big effect on people's lives. But in a country where 2/3 of the population live off the land, any improvements in agriculture are bound to have a massive impact.
One recent big success, fighting the Pigeon Pea Pod Borer.
So these larvae, these will affect any and all plants, is that right? Or a lot of the legumes?
It's polyphagous. They not only legumes, it can go for cabbage, cauliflower, cotton, chilies, all cultivated crops. So it's the #1 enemy of agricultural crops in Asia. And in fact, we are spending about 500 million worth insecticide to control only this pest. And the loss caused by this pest is about $2 billion.
The answer, a biopesticide, NPV. Developed with the help of farmers who are encouraged to shake down their bushes to collect the larvae themselves. These are then used as the raw material for the biopesticide. This is then sprayed back onto the crops to protect them.
You get a lot from one bush, don't you?
A more effective solution to traditional pesticides which become ineffective over time.
It's very difficult to put this pest under manageable levels only through insecticides. So we all have to look for some type of integrated approach.
So the way you found is to use the insects themselves to develop an antidote to themselves, is that right?
Exactly. The farmers shake this pigeon pea plant during the peak infestation time, collect these larvae to produce the virus.
In the transgenic lab at ICRISAT, scientist Dr. Kiran Sharma grappling with another problem affecting the poorest of farmers, malnutrition.
One hunger is where people don't get enough calories, enough food to eat. The second type is more dangerous, where people think they are getting enough food, but it's not a balanced food. So that leads to what we call hidden hunger, where the major problem is deficiencies of essential minerals and vitamins.
The breakthrough in this lab, the world's first genetically modified groundnut, needed to avoid the health problems associated with poor nutrition.
What we're trying to tackle through this project, where we would like to have biofortified peanuts or groundnut which can add value to the people's lives.
The greatest satisfaction coming from scientific achievement that helps people through practical application. If you want an alternative take on science, then spend some time in a community that has an alternative take on life. To the people here, the sun plays an important role, serving not only the spirit, but also the stomach.
There's recharging your batteries, and then there's recharging your batteries. The International Township of Oroville is a well-known centre of spiritualism and alternative ways of living.
In the Matrimandir, the golden sphere at the centre of this idealistic community, the rays of the sun are harnessed and directed inside. They help illuminate the interior to create a space where the inhabitants can concentrate on finding their consciousness.
Don't bother me now, I'm busy.
In a place naturally concerned with using sources of energy friendly to the earth, it would be strange if the sun wasn't widely used. Solar power is collected by individual homes throughout the township, and on the roof of the communal kitchen, a 15-metre solar bowl.
This is a part of a sphere. It's the bottom third of a full sphere. It has a line focus where the receiver is placed. So something has to move to follow the sun, so the whole receiver arm there moves. That top point points at the sun. It's actuated by a computer and small motors, and it moves like a pendulum through the bowl once during the day.
A simple design and simple construction. 11,000 small square mirrors individually placed so they reflect the sun onto the swinging arm receiver.
The structure of the bowl is made from prefabricated ferrocement elements. So there's no metal structure below. It's made up of 96 pieces which we made on the ground and assembled them to get this spherical shape. So that's one aspect. And then the simple application of the mirrors done by ordinary team from the village which we had working with us. From the boiler room downstairs we have a small simple pump. It pumps water up this mast, down the arm, and then it comes spiraling up, and about halfway up it starts to turn into steam, and at the top we have a good steam production, then out the insulated pipe back to the kitchen.
Let there be steam. Pumped back into the kitchen below, the steam needed for the hundreds of meals cooked here each day. Operated in tandem with the kitchen's diesel boilers, staff have found they can save 20% of their fuel costs, all thanks to the sun and a little alternative thinking. Evening on the coast of Goa. Deceptively calm on the quayside. Go beyond the harbour wall and there's no protection from the stomach-churning monsoon swell. From our small fishing boat, trying to scale the towering sides of the Sagar Kanya, an adventure all its own. Buffeted and banged against her steel for half an hour, it's decided. Our gear goes up in the cargo net and we go up the rope ladder.
So late at night here just off the coast of Goa, we've finally made it on board through the heavy swell. Us, our equipment in the cargo net, and about to find a cabin, hopefully. This is the dirty end of ocean research, as you can see from my trousers here. Time to go and find a cabin and move some boxes.
Signing on for our cruise, we're following in the footsteps of a generation of oceanographic scientists. The Sagar Kanya is something of a floating institution. Commissioned in 1983, the vessel has been the flagship of India's research and exploration endeavours on the high seas.
Sagar Kanya, it means the daughter of the oceans, the daughter of the sea. And it's quite a prestigious vessel with India, built in 1983, it's around 24 years old. It's a multidisciplinary institutional vessel, and practically all the science institutions in India, they make use of this vessel, whether it's the universities, it's the government organizations, it is the research institutions. It has got biological labs, it has got marine geological labs, geophysical labs, all sorts of geophysical equipments it has gravimeters, it has sub-bottom profilers, everything that you can think of.
Our journey is taking us westwards into the Arabian Sea. But throughout the year, the vessel is kept constantly busy with missions not only on this coast, but also in the Indian Ocean and the Bay of Bengal. On these trips, it will constantly sample the seas, taking measurements for many different properties, from salinity and temperature to the existence of plankton and dissolved nutrients. Samples are then analysed in one of the ship's 14 different laboratories. It all contributes to India's understanding of the seas and weather patterns that surround its vast coastline, and which affects such universal phenomena as the monsoon.
The sensors and samplers on this side of the vessel are largely concerned with testing the properties of the seas we're passing through. The ones over this side go much deeper, down to the seabed itself. For despite all our knowledge of the world and the way it works, the ocean floor itself remains a relative mystery, but one of boundless potential.
As the world searches for more of the minerals and raw materials that are becoming depleted on land, so increasingly the search is turning to the ocean floor. And India, like every other maritime nation, has recognized the importance of so-called polymetallic nodules. These potato-sized nodules, which carpet the floors of deep oceans, are a rich source of many strategic metals, such as nickel, copper and cobalt.
India is one of the few countries which has got the capability of locating these nodules, and we have already got some area identified where we can extract it. So we are now doing some pilot plant extraction techniques, how it can be taken out, where it can be taken out, and how that metallurgy can be evolved to get the metals out of these nodules.
Thanks to deep ocean research, a large area of the Indian Ocean has been identified as a rich source for future development, and India has been granted United Nations status as a pioneer investor. For the maiden of the oceans, the Sagar Kanya is maturing nicely. But she is kept constantly young thanks to technological innovation, like the state-of-the-art satellite positioning system that ensures a perfect course for precision surveying work.
The interactive studies between the atmosphere and the ocean, that is the main area of our scientific research, wherein we try to study the monsoons.
Such upgrades mean there are many more voyages in her yet, enabling many more discoveries. And as we headed back under those monsoon skies, so the gathering of the data continued, contributing ever more to our knowledge of the physical world around us.
And it's here on the Sagar Kanya that our safari has come to an end. Of course, the stories we've been covering are never-ending. By their nature, these innovations are always moving forward to their next stage of evolution. From all of us on the Science Safari team, goodbye.